Hi, welcome back. Today we're going to evaluate limits algebraically. So before this, we looked at them graphically. Now we're going to be looking at them without the graph. So there's a few different methods to evaluating limits algebraically. One being direct substitution, the next being factoring, the factoring method, expanding method, conjugate method, common denominator method, and the trigonometric identities method. So the first one we're going to look at is evaluating limits using direct substitution. So direct substitution method sounds exactly just as it says, using direct substitution. So what we're going to do is directly substitute in to this function, x approaches 0. Everywhere where you have an x, you would substitute in 0. So in this case, you plug in 0 for x, everywhere you see an x in the function. So if we evaluate this, e to the 0, anything raised to the 0 power is 1 based on your exponent rules. And then the other piece, the tangent is 0 and the cosine is 0, you kind of need to know your unit circle to know what those values equal. So if we think about our unit circle and you think about 0 degrees, 0 degrees is over here. And the coordinate point at that location for 0 degrees is 1, 0. Well, remember a tangent of 0 is y divided by x. 0 divided by 1, 0 divided by anything is 0. But cosine is always the x value on the unit circle. So in this case, 1, 0, cosine is 1. Cosine of 0 is 1. So then if we continue to evaluate on the numerator, 1 minus 0 is 1. 1 squared on the denominator is 1. And 1 divided by 1 is 1. So that means the limit for e to the x minus tangent of x divided by cosine squared of x as x approaches 0 is going to approach the value of 1. So the limit is 1 in this case. Evaluating limits using the factoring method. Well, first, let's try the direct substitution. If we plug in 4 into this equation, 4 squared minus 7 times 4 plus 12, all divided by 4 minus 4. On the numerator, we'd have 16 minus 28 plus 12 all over 4 minus 4 is 0. And if you keep going, 16 minus 28 is negative 12. Negative 12 plus 12 is 0. So we have 0 divided by 0. Well, 0 divided by 0 is an indeterminate, which means direct substitution did not exactly help us evaluate this limit here. So we want to use some different method. In this case, the factoring method. So if we take the numerator and factor it using what we know about factoring quadratics, then the two factors of 12 that add to give you negative 7 would be negative 3 and negative 4. So we see here that when we factor the numerator and denominator can now cancel out what they have in common with an x minus 4 on their numerator and denominator. So therefore, we're left with x minus 3. Now, if we use direct substitution, 4 minus 3 would equal 1. So therefore, this limit actually approaches 1. Okay, another factoring example that I have here is just a different kind of factoring. If you remember, when there's 4 terms, you can most likely look to see if you can do factor by grouping. So if we factor out the GCF of the first two, which is x squared, then you're left with x minus 8 on the inside. And then for these two, if you factor out the GCF of negative 4 and 32, the GCF would be negative 4. And so if you put that numerator together, then you factor out the x minus 8, and you're left with x squared minus 4. And all divided by x minus 8, since that was the denominator for the limit as x approaches 8. So now this is what this function factors to: x minus 8, x squared minus 4, all over x minus 8. So it looks like we can reduce the x minus 8 on the numerator and denominator. And now if we directly substitute in 8, we have 8 squared minus 4, which would be 64 minus 4, which is 60. So therefore this limit evaluates to 60. Our last example that we're going to look at for the factoring is has you recalling the sum and differences of cubes. So if you look to the right-hand side, this is a reminder of what the differences of cubes formula is. So in this case, if we were to plug in -5, again, on the numerator and denominator, we get 0 divided by 0. So therefore, we have to use the factoring method in order to solve. So that numerator, according to our rules, using the sum and difference of cubes would factor to x plus 5. And then since that's your a and that's your b, that means that your a squared would be x squared minus your a times b, 5 times x would be 5x. And then your b squared would be 5 squared, which is 25, all over x plus 5. So in this case, on the numerator and denominator, we would be able to simplify out the x plus 5. So for the limit as x approaches -5, if we now substitute in -5 everywhere, well, -5 squared is 25. -5 times -5 is 25. Plus we have 25. So 25 plus 25 plus 25 would evaluate to 75. So our next method for evaluating limits algebraically is the conjugate method. If you remember, a conjugate is where you take two terms, the two terms typically on the denominator, and you multiply it by the opposite sign that's in the middle. So everything else stays the same. So in this case, the conjugate, you'd have x square root of x minus h and square root of x. But then the conjugate of this piece, because it's a negative sign, you change it to a positive sign. And of course, algebraically, if you're going to multiply something by the denominator, you must multiply it on the numerator as well, because now technically we're just multiplying it by 1. So then if we continue to evaluate this on the denominator, we'll multiply it by the conjugate, but the numerator we just keep as is, because more than likely things are going to cancel. So we'll leave it as -h times the square root of x minus h plus square root of x. But then on the denominator, if we FOIL all that out, now when you FOIL two things that are the exact same thing but just opposite signs in the middle piece is always going to cancel. So really we just need to multiply the first two terms and the last two terms. So the first two terms, square root of x minus h and square root of x minus h, that just equals x minus h, right? Because the square root of x cancels out. But then here we have negative square root of x times positive square root of x. Well, a negative times a positive is negative, and then square root of x times square root of x is x. So if we continue on with our algebra, x minus x would equal 0, so we can go ahead and cross that out. And then further, if you see on the numerator and denominator, we have a -h divided by -h. These are being multiplied, so we can absolutely reduce that to 1, because -h divided by -h is 1. So then from here, we can finally do the direct substitution. In this case, it says h approaches 0, so we'd have x minus 0, square root of x minus 0, plus square root of x. Well, x minus 0 would just be x, so we have square root of x plus square root of x. And square root of x plus square root of x would equal 2 square root of x. So in this case, this function, this limit, approaches to square root of x. The common denominator method. The common denominator method, again, is how it sounds, so you have to get common denominators. So if we look at this problem, 2 plus h and 2 do not have the same denominator. So I'd multiply this first one by 2 on the numerator and denominator. And I would multiply the second one by 2 plus h. So if I multiply straight across, 2 times 1 is 2. And then minus, if I distribute that negative 1 to everything, negative 1 times 2 is negative 2. And negative 1 times h is negative h. All over that denominator of 2 times 2 plus h. And it's all divided by h. So 2 minus 2 is 0. So we can go ahead and cross that out. And then I have a fraction divided by a fraction. This h is technically over 1. So if I keep change flip that, I have the limit as h approaches 0 for negative h all over 2 times 2 plus h. Keep change flip, h over 1 becomes 1 over h. So now, since everything is being multiplied, I can cross out my h's because h divided by h equals 1. So I'm left with the limit as h approaches 0 for negative 1 on the numerator and 2 times 2 plus h on the denominator. So now if I actually do direct substitution and plug in 0 for h, then I'd have negative 1 over 2 times 2, which is 4. So the limit for this function using the common denominator method is negative 1/4. Our final method for evaluating limits is the trigonometric identities method. And again, it's exactly as it sounds. If you're not sure what your trigonometric identities are, I do suggest pausing this video and go looking them up. Maybe Google trigonometric identities and a slew of things come up. So for example, in this one, if I did direct substitution right now, well, sine of 0 is 0 on the unit circle. Tangent of 0 is also 0. So again, we'd have a determinant of 0 divided by 0, which means we need to use some identities here to simplify it. So if I use my quotient identity of tangent is the same thing as sine of x divided by cosine of x. And it's all being divided by sine of x, which you know sine of x as a fraction is sine over 1. Then if I keep change flip this, I have a fraction divided by a fraction. Keep change flip, I would have 3x times sine of x over cosine of x. When I keep change flip it, sine of x divided by 1 becomes 1 over sine of x. So you see here everything's being multiplied. The sine of x would reduce. So I'm left with the limit as x approaches 0 for 3 of x over cosine of x. So now if I do direct substitution, then I have 3 times 0 over cosine of 0. Remember, cosine on the unit circle is 1. 3 times 0 is 0. And 0 divided by 1 is 0. So that means the limit for this function is 0. Now for my next one, I have the limit as x approaches 0 for 1 minus cosine squared over sine squared of x. Again, your identities, if you remember your trigonometric identities, sine squared is the same thing as 1 minus cosine squared. So if I substitute in the fact that sine squared, according to our Pythagorean identity, is 1 minus cosine squared, then I have 1 minus cosine squared is factorable. So if I take this 1 minus cosine and factor that to 1 minus cosine and 1 plus cosine. Notice on the numerator and denominator, I could cross out my 1 minus cosine. So then that means I'm left with the limit as x approaches 0. Considering everything crossed out on the numerator, I'm left with a 1 as a placeholder over 1 plus cosine of x. So now if I actually substitute in 0, remember earlier we said cosine of 0 is 1. So therefore I'd have 1 divided by 1 plus 1, which would be 1/2. And that is it for evaluating limits algebraically.